how to find the minimum cost for a minimum spanning tree approach. Clear? Now, I'm going to share my whiteboard. Okay. After that, we'll try to enhance how to find a minimum cost for a given spanning tree. Yeah. Okay. So let us start. Now, please observe your whiteboard. Is it readable? Please message me through your message box. Other guys can see my classroom board. Please message me. Okay. So observe my slide here. So let us take a small example to illustrate a minimum cost for a given spanning tree. Clear? Now, if you observe my screen, here I splitted my screen into two parts. On one side of my screen, I have shown the slide, and the other side, I am going to explain this slide, okay, so that you can easily understand the concept. So, in the last session, we have talked about a spanning tree. Okay, now I'm going to consider a small spanning tree. Okay, let us say this is one node named as A, this is B, this is C, and this is D. Clear? Now, in this concern graph, what I'm going to do is I'll plot my edges like this. So those are called the vertices of a given graph, and these are called the edges of a given graph. Let us consider a simple graph with their respective weights also. Now, the edge between these two, we know that this is a node named as A, this is a node named as B, this is a node named as C, this is a node named as D. Now, the edge across A and C is 2. Let us say the edge across A and B is 1, and the edge across A and D is 3, and the edge across B and D, let us say it is 4, and the edge across C and D, let us assume that it is 5. Now, for this concern graph, we have already learned that there are n number of possible ways to get a spanning tree with a formula called n equal n to the power of n minus 2. And I have already illustrated all those possible graph trees for a given graph. Okay. So we have assumed 4 means we are going to get 16. If I assume n value as 3, we will get 3. Now, to this concern graph, how to find a minimum cost? Let us say the spanning tree can be the first possible way let us assume that I'm going to consider this is my first possible way. This is 1, this is 2, this is 3. So there is a possibility of connecting to your concern nodes, and the possibility can be in any aspect to possible way where we have learned the possibilities in our last session. Clear? Similarly, if I observe, okay, now based on this, how many number of possible ways that I can assign to your concern graph means, if you observe the screen, okay, now this is one way where observe my cursor on the screen. Now I'm going to show my slide. This is the edge called 1. This is the edge with a weight called 4. This is an edge with a weight called 5. Therefore, if I find the total cost of this consent tree, I've found to be 5 plus 4, 9, 9 plus 1, 10. So for this consent tree, the total cost achieved is 10. Repeat the same procedure for the remaining possible ways of a consent spanning tree. Now if I observe this, again repeat this 1, 2, 4. Okay. Therefore, 4 plus 2, 6, 6 plus 1, 7. So in the second tree, I have the total cost as 7. In my third, 4, 2, 5. Now it is, I think, 5 plus 4, 9, 9, 9 plus 2, 11. Okay. Is my screen visible to you? And whatever the things that I am going to elaborate on the slide, can you see that? Please message me. Yes. Okay, thank you. Now the next important point is, if I found the total cost achieved from this consent tree is 5 plus 4, 9. I think this is 5 plus 2, 7, 7 plus 1, 8. Similarly, for this 1 plus 2, 3, 3 plus 3, 6. Similarly, for this consent possibility, we may have, okay, 4 plus 3, 7, 7 plus 5, 12. Now, if we observe the total cost achieved in each and every individual tree, for a consent tree where the cost is minimum, that consent tree is termed as minimum cost spanning tree. So in this example, I can say that 6 is my minimum cost achieved out of all 5 different or 6 to 7 different possible ways where we can frame your consent tree. Is this clear? Therefore, the minimum cost spanning tree can be defined as, for a given graph, if the cost has been calculated individually in different possibilities, out of all different possibilities, wherever I found my possibility with a minimum cost, that consent tree is termed as your minimum cost spanning tree. Is this clear? Is my topic clear? Any more doubts? Please message me. Is my topic clear? Very good. Now, based on this knowledge, today we shall discuss about the minimum cost spanning tree of different algorithms. Okay, we shall see how to find a minimum cost using a Prim's algorithm, and we can see how to find a minimum cost for Kruskal's algorithm. Clear? And we will see one by one with an example. Clear? Now, shall I clear my board? Message me. Is it clear? Yes. So the next topic that I am going to deliver is your Prims and Kruskal. Clear? So for that, what I'm going to do is, I'll take one more example to illustrate these two algorithms. Clear? Now, let us start the Prim's algorithm. Okay. Now I've shared my slide. Okay. And on the other side, I'll try to elaborate the content of this algorithm. Clear? Observe this algorithm and please make a note that we are supposed to consider two basic parameters first. One is called input, the other one is called output. The input should be undirected connected weighted graph. Clear? Means there should be some weight and it should not be connected. It should be undirected. Means the graph should be connected with undirected symbol. Means you are not supposed to post any kind of arrows in this. That is what the meaning of undirected connected weighted graph. Clear? To this undirected connected weighted graph, okay, how to find a minimum cost spanning tree using your algorithm called Prim's algorithm. Clear? We shall see that. In the meantime, please make a note of it on your running notes. Now I'll plot the same graph here and then I'll show you the minimum cost spanning tree of it. Clear? Is my voice and the respective slide clear to you? Please message me. Yes. Now, first of all, consider your concern given graph with how many nodes? 1, 2, 3, 4, 5, 6, 7. So we are going to draw a concern graph on the other side of my whiteboard. Okay. Observe this. Let us say this is my vertex named as A. And this is my vertex named as B. This is my vertex named as C. Is my screen visible to you? Please message me. Yes, thank you. Now, let us say this is my node point or vertex, we can say, or else we can define this as node also. Clear? And let us assume that this is another node called E. This is another node called as F. And this is another node called as G. Clear? So now I am going to make my undirected connected graph. Clear? With weights inside in between two node points. So the weight assigned on this is, say, let us say 10. And the weights assigned in between these two vertices is, let us say, it is around okay, 28. You can weight any number as you wish. Okay, it is not so essential to make the same weights and plot your respective graph. Okay, now I'm going to consider one more weight in between D, F. Okay, fine. So after framing this, what I'm going to do is I'll use all my weights 25. The other one is 26, and this is 22, this is 12, this is 18, and this is 16, and this is 14. Okay, this is what the given undirected connected weighted graph. Okay, is this clear? Please message me. Yes, thank you. Now what we need to do is, here we need to follow three major steps. Step number 1, select any vertex from the given graph. I am going to consider the starting vertex as A. So I am going to assume that this is my starting vertex. At each stage, select the edge of the smallest weight joining the vertex already included to the vertex not yet included. Means we need to consider, if this is your vertex A, this can have an edge between B as well as C. But here what we need to do is, we need to consider only the least or the smallest weight that is arrived for this concerned vertex. Therefore, I conclude that if I compare a comparison between 10 and 28, I found that 10 is the smallest weight. Therefore, from A, it has arrived to B. Is this clear? Please message me so that further I can continue. Yes. Thank you. Now, the next important point is, now the node point from A has arrived to B. Now, we need to proceed further until all the respective vertices are being traced. So, if you observe this B has only one respective weight, and that weight is assigned to E itself. So, there is no comparison. So, you can travel from B to E. Is this clear? Any more doubts? Now, if I use further from E, there are two basic edge weights, one across D with an edge with a weight of 26 and two with a weight of 22. Clear? Now you need to judge which is the smallest weight among these two, and that weight should be traversed further to the consecutive next vertex. So there is a provision that from E you can go towards D, or from E you can go towards F. But here this Prim's algorithm, minimum cost, the minimum cost that is arrived for these two weights across D and across F, we found that 22. Therefore, from E it has traveled towards F. Is this clear? This is what the most important point while framing your Prim's algorithm. Is it clear? Please message me. By seeing your messages, I can further proceed. Okay. And if you feel any doubt, please message me so that I can repeat the concept once again. Very good. Thank you. Now, the next important thing is, we have achieved the path up to the vertex F. Now we have from F, there are two possibilities where we can go towards D and where we can go towards G. Clear? But here, when I use, okay, these two, what is the minimum cost here? The minimum cost is 12. Therefore, I give permission to gather the vertex for the minimum cost that can be achieved towards the vertex G. Is this clear? Next, from G, there is only one respective weight, so there is no need of comparing your comparison. And from G, it has achieved to C. Now, from C, there are again two possible weights. One is across 14, which is traveling towards vertex D, and two is across A, which is traveling to with a weighted cost of 28. Therefore, out of these two comparisons, I found that the minimum cost is 14, so I give a permission to travel from C to D. Clear? Now, when once D has achieved, here comes the most important point. D has two basic parts, one towards E, the other one towards F. But before going to check your respective weights, see that whether it is a cycle or not a cycle. Here, for this Prim's algorithm, we can find the minimum cost of a consent tree if it is not a cycle. That is what we have learned in the last session. Therefore, a graph has a cycle, a tree doesn't have a cycle. Therefore, if I permit the path from D to F, it will be a cycle among these 3 or 4 respective nodes. If I give a permission among D to E, I can have a cycle among these 5 basic nodes. Therefore, if you connect from D to E, it will be a cycle, and the cycle can be C, D, E, F, G. Or else, if you connect D and F, this is also will be a cycle, and the cycle approach will be C, D, F, G. Therefore, in Prim's algorithm, we need to conclude the minimum cost provided if it is a tree. So to make your concern undirected connected weighted graph as a tree, see that there should not be a cycle. After fulfilling that, now we need to find the total cost of it. So what is the total cost from A to B? It is 10. Is it clear? Shall I proceed further to find the minimum cost of a concern graph? Please message me. Very good. Please feel free to post your doubts on the message box. Okay, so that I can repeat once again. Clear. Thank you. Thank you. Now, the next important point is how to find the total cost of it. So to find the total cost of it, here from A, we have path towards B with a cost 10. From B, we have path towards E with a cost 25. From E, we have traveled towards F with a cost 22. From F, we have traveled towards the vertex G with a cost 12. And from G, we have traveled towards C with a cost 16. And from C, we have traveled towards D with a cost 14. Now, if I add all these, that will give you the total minimum cost required to travel all the given vertices, and hence this algorithm is termed as Prim's algorithm, which is used to find the minimum cost spanning tree. So once again, I'm going to repeat the most important point. Graph has a cycle, tree doesn't have a cycle. We need to be so careful while framing your minimum cost that minimum cost of a consent spanning tree, there should not be a cycle. Don't simply found out the minimum cost and add your respective vertices. Clear? Check before identifying the minimum cost. Check whether the vertex has a cycle or not. If it is not having a cycle representation, you can proceed. If it has a cycle representation, you are not supposed to proceed. Why? Because in this entire graph, if you observe the point from this concern node D, there are two possibilities. Most of the students will do that. The minimum cost is 18, so I'll give a permission to travel from D to F. If once you connect this line, this is invalid and you are going to lose the mark in your final exam. Why? Because this will be again a graph, not a tree. Is it clear? Any more doubts? So I'll give you some 2 minutes time so that you can draw it and you can cross check your answer. Thank you. Please message me. Okay, whatever may be the doubt that you are going to face in your respective topic, you can message me so that I can clear it. Very good. Thanks for your feedbacks. Okay, fine. Shall I start the next concept? How to find a minimum cost using Kruskal's algorithm. Shall I start that? Please message me. Very good. Okay, fine. Okay. Now try to practice the examples for Prim's algorithm in different graphs. Okay, almost it is around 9:40. Now I want to instruct some instructions. So tomorrow I shall continue about Kruskal's algorithm. So the guys who have written their exam today after this class, I'll send their marks to their respective domain. Clear? So click on the concern URL link. Check whether the mark has been achieved. If you feel any inconvenience in wrong posting your mark, please message me so that I can cross check again. Okay. And the last important point is when the questions have been given in your respective classroom, please try to take at least 5 to 10 minutes of time to submit your answer. If once your assignment has been submitted, you are not supposed to submit again. Even though you submit your assignment twice or thrice or four times, okay, whatever may be n number of times, it will consider only the first submitted form only. That is the most important point which you need to remember. Okay, so on this environment, even you can write some assignment questions also. For the meantime, 1 to 2 classes, okay, let us discuss the assessment of your concern assignment in multiple choice. Okay, but don't simply tick your mark, okay, without reading, or don't kindly, okay, assign your answers in a vague mode. Please go through your questions carefully, learn them, okay. Think about your subject, recall your subject once, and then answer your question carefully. Yet today I will send the answer sheet of your assignment number 1, which we call them as a response sheet, in your concern group. Along with that, the next assignment link also I'll post it in your group mail IDs. Okay. So please go through your group and check once again. Thank you one and all. Okay. Thank you. Now, please wait. I'm going to consider your online attendance here itself. The total strength for today's session is 26. Is it clear? Can anyone answer this? Harshita?
Yes, sir. Yes, sir.
Is it 26? Yes.
Yes, sir.
It has been recorded in your sheet itself. Is it
Yes.
equal?
Yes, sir. It is equal.
Thank you. Thank you, Amma. Now you can leave my session. Tomorrow we shall see the next algorithm, Kruskal's algorithm. Thank you.
Sir, attendance.
It has been posted, right?
Thanks.
Hello. Sir, good morning, sir.
మన నెక్స్ట్ క్లాస్ ఉందిరా మళ్ళా.
Sir, no such small doubts, sir. Ante sir, small.
మెసేజ్ మీరా, ఓకే?
Okay, sir, then.